Solving inequalities graphically. Start with a couple of graphs to get the idea, and then we'll show how we can do this using the graphing calculator. So in this graph, we see the graphs of y equals 2x minus 5 and y equals negative x plus 7. We're asked to use the graphs to solve the following statements. The first statement is the equation 2x minus 5 is equal to negative x plus 7. So the graph of y equals 2x minus 5 is in red in this graph, and negative x plus 7 is in purple in this graph. So where is 2x minus 5 equal to negative x plus 7? Well, graphically, we see that they are equal, the y values are equal at the point of intersection. So notice that they intersect at the point 4, 3. So what we will understand is that therefore the solution of the equation is x equals 4. The y values are the same, 3, when the x value is 4. So notice if we were to substitute back into the equation, 2 times 4 minus 5, that's 8 minus 5 is 3, and opposite of 4 plus 7, negative 4 plus 7 is also 3. 3 equals 3, that's our check. That happens when x equals 4, so therefore the solution is x equals 4. Now what I like to do at this point is to draw a boundary. So there's the boundary at x equals 4. Because now we want to solve the corresponding inequality, 2x plus 5 is greater than negative x plus 7. So 2x plus 5 is represented by the red line, and negative x plus 7 is represented by the purple line. And so we need to decide when is the red line above the purple line. And the answer is either to the left or to the right of the boundary. So the red line, the 2x plus 5, is above, so 2x plus 5 is above negative x plus 7 to the right of the boundary. Now the boundary is at x equals 4. So therefore, to the right of the boundary means x is greater than 4. And that is the solution of the inequality. Notice that it has that same boundary value, the 4. So the solution of the equation and the solution of the inequality are related. The solution for the equation will show up in the solution of the inequality. Let's see another example of that. So here we have the graphs of y equals negative 1/2 x plus 3 and y equals 2/3 x plus 10, and we're asked to use these graphs to solve the following statements. Where is negative 1/2 x plus 3 equal to 2/3 x plus 10? Where is negative 1/2 x plus 3 greater than 2/3 x plus 10? All right, again, negative 1/2 x plus 3 is the red line, and 2/3 x plus 10 is the purple line. So again, we would ask ourselves, where do they meet? Well, they meet right here. There's the boundary, when x equals negative 6. So the solution of the equation is x equals negative 6. Now we have the inequality. Where is negative 1/2 x plus 3 greater than 2/3 x plus 10? So where is the red above the purple? Where is the red above the purple? Well, in this case it happens to the left of the boundary. Okay, well the boundary value is negative 6. So then to the left of negative 6 means when x is less than negative 6. So in general, to solve an inequality graphically, what we will do is obtain a graph of each expression contained in the inequality. We will determine the solution of the corresponding equation. And we think of this value as the boundary for the solution of the inequality. We determine on which side of the boundary the inequality is satisfied, and then we will write the solution in terms of the original variable and the boundary value. So if we wish to solve this inequality, 2.5x minus 1.4 is greater than 0.75x plus 3.85. Let's use the calculator to do this. What we will do is we will graph both of the expressions. So I will go to my y equals screen on the calculator, and I will graph as my y1 2.5x minus 1.4, and as my y2 I will graph 0.75x plus 3.85. Now my graphing calculator cannot show different colors, but what I can do is if I move my cursor all the way to the left on the y2, all the way to the left, right into this space, and if I hit enter one time, what it will do is it'll graph my y2 as a thicker line, so I will be able to clearly identify the two lines. Alright, so let me graph that on the standard window. So there's my graph, and my y1, there's the thin line, my y2 is the thick line, and I can see the point of intersection. Now let's calculate that point of intersection. Hopefully you've seen how to do this somewhere in the past, but if not, we can calculate the point of intersection by hitting second, and the trace key brings up our calc menu, and we choose the fifth option, the intersect command. Move left or right as necessary. I'm going to move right. I want to get close to the point of intersection, and hit enter 3 times. And so there's the point of intersection. Alright, so let me grab this and pull it down here. Alright, so there's that graph. Now, there's my point of intersection. So, if it were an equation, the solution of the equation would be x equals 3. Remember, that becomes my boundary. There's my boundary at x equals 3. I know you can't exactly draw on your calculator, but that's the idea. That's the boundary. Now, I can't do colors, so I want the thin line to be above the thick line. Where's the thin line above the thick line? The thin line is above the thick line to the right of the boundary. The boundary was at x equals 3. So therefore, to the right of the boundary, the solution would be x is greater than 3. Alright, another example using the calculator. Here we wish to solve the inequality. 2/5 x plus 3 is less than x plus 2.7. Again, let me bring up my calculator and my y equals screen. Let me clear out the old stuff. My y1 will be the 2/5 x plus 3. It's always a good idea to put those fractional coefficients in parentheses. My y2 will be the x plus 2.7. And again, what I'll do is move over to the left of the y2 and hit enter one time, and that'll make that a thick line. There's the graph in the standard window. And I will calculate the point of intersection. Pretty close as it is, so I'll just hit enter 3 times. So there's the intersection. Let me go ahead and grab that graph and bring it down. And enlarge it. Alright, so the intersection occurs when x equals 0.5, and again, that's my boundary. My boundary is at x equals 0.5. Now I have to decide, when is the thin line below, right, since it's a less than, where is the thin line below the thick line? The thin line is below the thick line to the right of the boundary. Alright, to the right of the boundary, so that's to the right of 0.5, so therefore the solution is x is greater than 0.5. So notice that even though the inequality started as a less than, by reading the graph correctly, we decide that the solution is to the right of the boundary, and so therefore we would write a greater than inequality.